Hello everyone, welcome to the session on basics of routing. In this session, we are going to cover basics of routing, types of routing protocols, routing table. Imagine you're in a new city, trying to find your way to the best pizza place. You pull up a map on your phone and it suggests multiple routes, some faster, some scenic, some with tolls. Your phone picks the best one based on real-time traffic. That's exactly what routers do in a network. They find the best path for data to travel. A router is like a traffic cop for data. It directs packets, small chunks of information between different networks. They ensure they reach the right destination. Whether you're watching a Netflix, sending an email, or playing an online game, routers work behind the scenes to make it happen smoothly. There are different types of routing. The first one is static routing. Here, you can see someone carefully marking a route on a map. This is like manually programming your GPS before a trip. You set a specific route, and that's the only way you'll go. No matter what happens, road closures or traffic jams, you'll stick to that path unless you manually update it. Network administrators use static routing when they want full control over where data packets travel. It's simple, predictable, and secure. But if something changes, like a broken road, it won't adjust automatically. It needs manual updates. The second one is dynamic routing, the Google Maps of networking. Imagine you're driving and Google Maps keep checking traffic conditions. If an accident happens ahead, it quickly finds a better route for you. That's how dynamic routing works in networks. It constantly learns and updates the best path for data to travel. Protocols like OSPF and BGP helps routers communicate and choose the fastest, most efficient routes, just like how Google Maps helps you to avoid delays. The third one is default routing, the go-to highway. Here, a confused driver at a crossroad, unsure where to go, then deciding to take the highway. Imagine you're driving in an unfamiliar area and you have no idea which road to take. What do? You hop onto the nearest highway, knowing it'll eventually lead you somewhere familiar. That's exactly how default routing works. When a router doesn't know where to send a data packet, it forwards it to the default route, usually a larger, more powerful router that knows where to go next. Do you all know how do routers decide the best path? They use routing protocols. They are distance vector protocol and link state protocol. Let's see how distance vector protocol works. Imagine an old school taxi driver who only knows distances but not the entire layout of the city. If you ask them to take you somewhere, they'll rely on word of mouth from other drivers rather than having a complete view of all the roads. That's exactly how distance vector protocol work. Protocols like routing information protocol send information about the number of hops to a destination, but it don't have a full view of the entire network. Each router shares its known routes with its neighbors, gradually updating information across the network. However, this method can be slow and insufficient for larger networks. Next, let's look into link state protocols. Think about a professional delivery driver who has access to a detailed city map and real-time traffic updates. They don't just rely on distance, they analyze road conditions, closures, and the best alternative routes to reach their destination quickly. This is how link state protocol works. Protocols like Open Shortest Path First provides routers with a complete network map. Instead of relying on neighbors for information, each router independently calculates the best path based on real-time network conditions. This makes link state protocols much faster, more efficient, and scalable for large networks. Now, we'll examine the routing table to see how routes are learned and managed in a network. In networking, routers play a crucial role in directing data packets to their destinations. But how do routers know where to send these packets? That's where the routing table comes in. To check a router's routing table, we use the command show IP route, which displays a list of all known routes, how they were learned, and where data packets should be forwarded. Understanding and verifying the routing table ensures smooth data transmission in networks. So next time you configure a router, remember to check its routing table using show IP route to ensure that packets are being forwarded correctly. This brings an end to our session on basics of routing. Thank you for watching.